So the simplifying of the radicals and rational exponents that we applied for numbers with numerically, we can also apply to variables. We do have to be a little careful here because with variables, we don't know the value if it's positive, negative, zero. So there's some other things sometimes we have to consider, and a couple things that change here a little bit when we're dealing with variables. The first is if you're, let's go with your index and exponent are odd, right? So if your index and your exponent are odd, right? So that will look something along the lines if we have an nth degree, or sorry, the nth root of x to the n, right? That when they're both odd, okay, well then the nth root of x to the n is just going to be x. Okay, no big deal. However, when the index and exponent are even, right? So if they're both even, then you have the nth root of x to the n, then that is going to be the absolute value of x. Okay. And here, if we look at two examples of these and you see why do I need the absolute value here? Well, if we have here, let's say we took the cube root of 3 cubed. Well, we could see this. So this is like my x here. You can see that if 3, right? Well, I have the cube root of 3 cubed will be the cube root of 27, which is, well, 3, right? You can see that this is just, well, x. And if I had the cube root of negative 3 cubed, and here's my x, negative 3, which here I know is negative 3, I'd say, well, what's negative 3 times negative 3 times negative 3? Negative 27. And what's the cube root of negative 27? Well, negative 3 times itself 3 times is negative 27. So negative 3. So we could see that. When I have the cube root of 3 cubed or the cube root of negative 3 cubed, I just get exactly what I'm cubing here. In this case, 3. Okay, so relate that here, that x, 3, 3, negative 3, negative 3. And those odd and odd. Okay. But over here, what happens? Well, if let's suppose we thought it was x and we look at it and say, well, what's the, let's say and we'll keep it kind of simple. What's the square root of 2 squared? And you go, oh, the square root of 2 squared is, well, 2 squared is 4. And the square root of 4 is 2. And you go, okay, well, isn't just that equal to x? Well, the problem comes in, well, what about when it's negative 2 squared? So if I thought, oh, it's just going to be whatever I'm squaring. If I thought, question mark, this was going to be negative 2, well, look what happens. Negative 2 squared is 4. The square root of 4 is 2, which is not equal to negative 2. That's why we're going to need the absolute value. That is now true. Okay. And over here, since we don't know what x is, if x is positive or negative and can be positive or negative, then when we take the nth root of x to the n, where n is even, we're going to need the absolute value. Okay. So little nuance there, something we have to consider. Now, if all variables are positive, right? So if we just know in the context that the variables are positive, right, or if they're assumed to be positive, right, if there's a reason that we know that x can't be negative, then no absolute value is needed. Right. So if all variables are positive, then we don't need absolute value. Okay, we're not going to need our absolute value. So we got that. Now let's do a couple of these, I guess. Let's go with simplify, right? We'll just do one of these or two of these. The cube root, right, of 27 x to the 9th. Okay. So here, what I would generally say is we're simply the cube root of 27. So the cube root of 27 is 3, right? And now here, one way to think about this, and usually what's the easiest way for me to do it, I would think, is understand that if we convert just the x to the 9th part, the cube root of x to the ninth in terms of exponential form, okay, then that would be x to the 9/3, and then we could simplify it that way. Maybe even convert back to a radical form if need be. And you can see here that the cube root of x to the ninth would be x to the 9/3, and 9 divided by 3 is 3, so we get just 3x cubed. Okay. We have odd, don't need any absolute values. Okay. So we have that one. If we had something, let's go with the fourth root of x to the fourth over y to the eighth, like that. Well, here we have the fourth root of x to the fourth. We have the fourth root of y to the eighth. And you say, what's the fourth root of x to the fourth? Well, it's just x. Keep in mind here, I got 4 and 4. They're the same, and they're both even. Okay, I'm not told anything about x, so then I'm going to need absolute value around this. And then down here, right, what's the fourth root of y to the eighth? Well, if we convert this to exponential form, we'd have y to the 8/4, and 8 divided by 4 is 2, so we get y squared, right? So then there's that one simplified. All right. And then let's go and do maybe one more of those. How about this one? Let's go. And this one will assume variables are positive. So now we're not going to worry about, all right, we're told assuming the variables are positive. So let's simplify the fifth root of 4, a to the 8th, b to the 14th, and c to the 5th. Okay. Now, look at this one. You say, all right, well, this is essentially what you have. Without writing this out, this is what you really do have. You have the fifth root of 4 times the fifth root of a to the 8th times the fifth root of b to the 14th times the fifth root of c to the 5th. Now this, right, is this going to simplify? Well, yeah, it's because I have a to the 5th times a cubed. Right? A to the 8th is a to the 5th. Well, there's a perfect fifth power, so I got to get rid of that. B to the 14th is what? This is b to the 5th times b to the 5th times b to the 4th. That'd be b to the 14th, and you can see I have fifth power, perfect fifth power. And here I have c to the 5th. So now when I simplify this, I have the fifth root of 4, okay. I got the fifth root of a to the 5th, so times a, and then times, what do I have left? A fifth root of a cubed. Then here I have times a fifth root of b to the 5th times another fifth root of b to the 5th times then a fifth root of b to the 4th, and then times a fifth root of c to the 5th, which is just c. And then in the end, I'm generally not going to leave it like this. We'll go, all right, what do I have? I have a, b times b, a, b, c squared, b squared times c. And then what's left is a fifth root of 4, a cubed, b to the 4th. All right, so there's that one simplified. Now, generally, you're not going to write all this out, right? To me, a better way is understanding well what you're doing and understand that here, this is a to the 8/5. So, well, what am I doing here? Think about this. I could think of this as dividing 8 by 5, right? So if I take this right here, just let's look at this one, and I write this as 8a to the 8/5, and this is what I said before, and now write this as a to the what? 1 and 3/5. Now notice what? I have a to the first, right there it is, there's a to the first, and then what's left? A cubed, right there it is, a cubed. What about this? The fifth root of b to the 14th, right? The fifth root of b to the 14th, right, is going to be what? Well, this is b to the 14 over 5, which would be equal to b to the 2 and 4/5. And you can see, what am I going to have? I have b squared, right? So there's the b squared, and then I have left what? A 5th root of b to the 4th. Right there it is, 5th root of b to the 4th. And when you understand as well, then you go, oh, so that means I just got to take 14, divide by 5. 14 divided by 5 is 2, so there's b squared, the whole number comes out, and then I have left the b to the 4th underneath, okay? So that's how you should really simplify those, okay? So if you had something like, let's just look at the cube root of c to the 23rd, right? How do we do this quickly, right? Well, this is going to be what? Just divide 23 by 3. How many times is 3 going to 23? 7 times. So that means I'm going to have c to the 7th, right? 7 times 3 is 21. And then what's left? A cube root of c squared. Right? Because this becomes c to the 23 over 3. And if I write it as a mixed number, I have c to the 7 and 2/3. And here's c to the 7th, right there. And then c to the 2/3, which would be the cube root of c squared. All right, so that one's done. Okay. Beyond that, the only thing would be combine a little bit of everything, variables, like radicals, simplifying radicals. Okay, so if you had something like the square root of 9, here's another example. Okay, the square root of 9w to the 5th, and then minus w times the square root of w cubed. Right? You say, oh, simplify this, combine these. Well, in order, can you subtract these? These aren't like radicals. They don't have the same radicand. They have the same index. Okay. So generally, what you might want to do is simplify first. What does this simplify to be? Right. Well, I have the square root of 9, which is 3. And then keep in mind, there's a 2 here that we don't write. There's a 2 there. So I can take, well, what's 5 divided by 2? How many times does 2 go into 5? 2 goes into 5 twice. So I'm going to have w squared. And then there's going to be 1w left underneath. So that's going to simplify to that. Right? And another way you can, I have w what? I have w squared times w squared times w. That's why I had to take the square root of w times the square root of w squared. Another one, w times w squared, and then what's left is that 1w underneath. And then over here, we could do the same thing. I have the square root of w cubed. So, I have w squared times w. So I can say, what's the square root of w squared? A w times that w squared. And then again, I have left a square root of w. And we could also say, well, what's 3 divided by the 2 here that's implied? 3 divided by 2 is 1. So 1w comes out. And then I have left the remainder of 1w underneath. Here, what's 5 divided by 2? 2 goes into 5 twice. So 2 w's come out. There it is, w squared. And then 1w stays underneath, the remainder. And now if I have 3w squareds times the square w minus w squareds times the square w, how many square roots of these are like radicals? I can combine these. I have 3w squared minus w squared. I have 2w squareds square root of w. Never said w so many times in my life. There it is. All right, so that's simplified. So that's kind of the process and the things you just gotta work on of the best way to do it. To whether it's simplifying the radicals, rationalizing denominators, simplifying the stuff underneath the square roots or cube roots, the radicands, combining like radicals. Just get good by doing it. All right. And eventually it becomes pretty easy. So again, watch this over, check it out. If you have any questions, do not hesitate to reach out and we can meet and go over stuff.